Okay, so since mass can neither be created or destroyed, we need to make sure this chemical equation stays balanced, meaning that there's the same number of elements on this side as there is on this side. So your arrow helps you represent what side is what. Remember, these are your reactants and these are your products. So the amount of reactants needs to be equal to the amount of your products, okay? So let's look at our reactant side. Let's make our T-chart. We have Li and F on both sides. So on the left side, I have 1 Li, and on the right side where our products are, I also have 1 Li. So those are good. What becomes the issue is element F, fluorine. So on the reactant side, I have 2. This little 2 means you got 2 of them, but only have 1 on my product side. So let's try to balance this chemical equation. Okay, so what I can do is I can add coefficients in front of these elements and compounds. So if I put a 2 here, that means it applies to every single element within that compound. If it's just a little 2 on the bottom, it only applies to the particular element that is attached to. So when I put a 2 here, I now have 2 F's on both sides. But then that changes how many Li's I have on my product side. I now have 2 Li's and still 1 on the reactant side. So what I can do over here is put a 2 here as well. That makes me have 2 Li's. And then I can leave this guy blank or put a 1. Now, when you put a coefficient and there's a little number attached, you multiply them. So 1 times 2 gives me 2. So that means I have 2 element F's on the reactant side overall. So I got 2 Li's on my reactant side. 1 times 2 is 2 F's. So I have 2 F's on my reactant side. Now that needs to match my product side. 2 Li's on my product side and 2 F's on my product side. So everything matches up. I'm good. That means this equation is balanced. So the coefficients needed are 2, 1, 2. 2, 1, 2. And that is how we balance chemical equations. So use this knowledge you just reviewed to help you answer question number 2 correctly.